going to wait 1 more minute, and then we are going to start. All right, I think we can start. Welcome everybody to the 9th weekly dev call of Matchbox. I think everybody should be in the know what this is all about. It's basically to catch up on the progress of our grantees, see what they've been up to, what they've been doing, show off any kind of progress that they've achieved. And yeah, that's what this is all about. And this week we have a few updates. And let's maybe start with the introduction to the .NET SDK project. That's with Thomas. I think, yeah, I think it's Tomrox in Discord. So you're welcome to share your screen, or like if you want to, and just maybe introduce yourself and talk a bit about the .NET SDK project that you are going to be taking on for Matchbox as a grantee.
Yep, sure. So hi everyone, I hope you hear me well. So my name is Thomas. I studied computer science. During my studies, I was doing some internships in Web 2, building some stuff in C#, also doing some QA, working in some QA positions. And yeah, also always interested in blockchain and the whole ecosystem. And through some friendship, I went to the Starknet hackathon. That's where I met some of you guys, like Yoni and Seko. And yeah, I accepted. I mean, to work on this .NET SDK. Really excited to work on this to be able to build some stuff in Web3. Let's talk about that project a bit. So what's the idea? We want to build a C# library to interact with the Starknet network, and we're gonna use the Starknet JavaScript library as an example. We're still really early in the process. I have Seko that's helping me there to make sure I'm on the right path. And yeah, I think that's about it. Maybe Seko, you want to add something?
Yeah, so I think what's exciting about building the .NET library is that often we talk like how like on-chain games are just on-chain, then we can build different front ends for them, right? And now we see most projects are building like web games because that's where the tools are. And I think with the .NET SDK we can finally see like not only like browser games, but we can see mobile and desktop games. So like real games built in Unity with maybe a nice graphics and everything, right? And I think that's very exciting. I think that way the next wave of projects building Matchbox style will be like not just very cool like from a intellectual point of view, but also like they will look very cool. And I think it will be a way to attract more normal players to the ecosystem.
Yeah, that's awesome, and I think the .NET SDK project was actually like one of the first projects that we came up with at Matchbox, and ever since we've been basically looking for someone to take it on, right? Because you, Francesco, you didn't have enough time, and so you've been looking for someone. And it's really cool that we finally found someone who can take it on. Very excited about that, and yeah, just echoing what you said here, it's a great project to basically get games going that aren't just web-based games, right? That are making use of Unity, like proper desktop games, like the actual kind of thing when you think about gaming, right? It's like an actual proper desktop game. And so it's really awesome. It's really cool to have that connection to Starknet with the .NET SDK. So yeah, that's awesome. Thank you guys. Then next in line we have, let me see, I think AyeAyeCaptn, you're here, right? You wanted to give us a quick update on your game clock.
Yeah, so basically the quick update is that I've been I've created a priority queue for those tasks, and it basically has an priority to the task along with so it's a struct in Cairo, and it's passed along like so there is an array of structs that's being passed, and there's a basic operation of push and pop. So the lowest it basically puts it in the right position based on priority of the task, and that's the Cairo example that has been implemented. Apart from that, yeah, that's my update, and yeah, but the final code is still, I've not pushed it to the repository. I will update it like on the Discord channel when I push it on the repo. Yeah, that's about it.
Okay, awesome, thank you. And in terms of like next steps, what's the roadmap looking like?
So the next steps are basically this was just priority queue. Now priority queue would also work for this, but like I want to understand like how comparison between ability and priority queue and which one to follow. So I'm still looking forward to like which one to choose. But priority queue is already implemented. So uh, so the next step basically is to create a task which would now execute on Yagi. So now the next step is basically to have a task simple counter example which would be executing on Yagi. So the first thing would be to decide whether to use AVLT or priority queue, and the second thing would be to have a Yagi implementation of smart contract automation.
Okay, awesome. And in terms of a timeline, I think you were hinting at that you might be able to complete the game clock project a bit ahead of time. So in terms of timeline, what's the status on that?
So I think that I would be able to complete in 3 weeks or next 3 weeks. I would be able to complete the game clock project. Uh, the rest of the timeline, So the rest of the thing, I'm still discussing it with Yoni. So which one to pick, I have not decided. There are multiple things, and if like I think I will decide it after just when it gets completed. I will decide what to do next.
Okay, perfect. Thank you for this update. Looking forward to see the complete version, and then we can find out what you would like to work on next. That would be awesome. Okay, we have an update for Ogame on the schedule for this call. So Alex, if you want to give us an update, that would be awesome.
Hello, everyone. Hi. Yeah, so we got a couple of updates. One of which is that the compatibility of Ogame NFT is confirmed with Play Oasis Marketplace. So the NFT will be listed there. And also, I decided to make some changes to the design of the game. So basically, in the version 0.1, it was fundamentally monolithic. There was a main smart contract that was calling various libraries. The problem with this is that once the game is deployed, it cannot be changed. So after a bit of code, I decided to create a modular version. So basically, the game is composed by four main let's say, tabs. One is resources tab, one is facilities tab, one is research lab tab, and the third one is the fleet, let's say the fleet tab. So what I will do in the future is to have a main game contract, which will hold the game storage. So any asset or any progress will be stored there, and I will deploy 4 other different smart contracts separately. Each of which would be connected to the main game contract. The good thing about this is that this secondary smart contract would be the possibility to upgrade them, because they just will contain the game logic basically. So once the main game is deployed and the secondary smart contracts are deployed, we will be able to change the rule, maybe through voting, for example. So the player will be able to vote for the feature to be implemented. So I think this is cool. A different approach will be taken also for the storage. I will move from structs to old values for structures or fleets to single storage, which probably will save a lot of writes during the game. So these are basically the updates on the design. And for a couple of challenging that I'm facing at the moment is the growing complexity. The more the game grows, so the more feature I'm developing, the more moving parts are popping up everywhere. So keeping track of all of them is becoming a bit difficult. And also testing is becoming quite a big issue. This is because every time a test has to be run, a specific game state has to be built. So for the basic game states, it's quite quick. We're talking about a few minutes. But for the more advanced game states, I see that already it's going to take 15 minutes to run a single test. So I will need to find a different approach to that. And I was honestly thinking to kind of develop a God mode. So a specific state, I will be able to create a specific state of game just with one operation basically. So I didn't develop anything yet on this, but that's the idea. So if anyone wants to contact me and try to help me with the testing, that would be great. And that's basically it.
Okay, awesome for the update. So let me quickly recap. Essentially, you've been moving from a monolithic structure to a modular structure, which I assume gives you more flexibility in terms of what you can implement. Then you talked about, I think, that you want to enable players voting on what kind of things to implement. Did I understand it correctly?
Yeah. Yes.
And then you touched on the kind of testing issue where the complexity is slowly growing and you are running into issues where you have to create a game state that is more advanced, which takes you a good amount of time. So you're looking into developing a kind of God mode so you can quickly create that to facilitate the testing.
Yeah, that's correct.
And I think you also mentioned, not on this call, but in Matchbox in general, that you might be looking for some back-end help.
Oh yes, mostly on testing at the moment. It takes a long time to develop both smart contract and test together. So having someone looking into testing, it would be amazing.
Right. Okay. Yeah. We'll be on the lookout to find someone to help you. And if anyone here is interested, then please reach out to either Alex or me, and we will set you up and get you in touch.
Thank you.
You're welcome. Okay. Awesome. Yeah, or does anyone have any kind of questions or remarks for Alex and Ogame? Okay, then let's move on to our next agenda point, which is an update on the music tools, the on-chain music tools that Casey is working on. It's super great to see that you've already been progressing. Very much looking forward to what you've been up to, Casey.
Hey everyone. Yeah, it was a big week for MusicTools on Starknet and the sort of game audio engine development idea. And so I was, researching and was fortunate to talk to a ton of experts on, topics of like latency, on and off chain game states, game UIs, and audio engine. And talking to them really helped sharpen the boundaries of the project and help identify, the tech solutions needed for this project. And here's just kind of a as brief as I can to kind of walk through of kind of what I got. So with latency, there's these kind of major considerations that, latency is in a system is at least, greater than or equal to the slowest node in the system. And, for games, latency for audio events and even game events should ideally be sub 20 milliseconds. And, 20 to 100 milliseconds is acceptable for kind of limited scenarios, but, hair trigger gamers are going to kind of really notice this sort of stuff. And another thing to mention is that querying game data introduces latency, and Biblioteca DAO with Realms has mentioned that it's since it's not feasible to make massive requests to Starknet, some games are using state caches accessed by WebSockets and subscriptions to expose their on-chain state indexes. And what that kind of means is, like their GraphQL query latency, those things are affected by server location distance. And so a query from a nearby server would be like 5 milliseconds, but a long one could be like a couple hundred milliseconds. And so there's sort of, given the variable latency of a lot of the on and off chain data, there are limited scenarios in which that data can be kind of integrated into audio events, or it's got to be done in sort of, maybe sort of specific, adds attributes or that sort of thing. And so, like usually that these sort of queries to this sort of data would be like for updating stats or ranking on players or realms or that kind of thing. And so I was fortunate enough to chat with the Dope Wars devs, and it became clear that the game behavior for their MMORPG is focused on in-client UI behavior. And in order to give audio to provide audio to games, the audio engine essentially is going to need access to the game's UI. And it's sort of another level of openness and sort of composability, but it just happens to, probably it's happening, at the UI level and not the contract level. And that's kind of the real ticket to getting, this sort of like responsive, user-based, event behavior out of, an audio engine. And so the Dope Wars devs have been super helpful, and they've pointed me to their UI, and so I've got links to their WebSockets and all of their possible user interaction and how they handle oncoming messages from the client to the server. And in the case, the focus really does have to be on the sort of client side, because their game servers are just middlemen between players, and it's syncing data, not really creating events. And I should also add that Biblioteca DAO has been really helpful too. They've helped me connect to their Starknet indexer and compose queries, so I could get a sense of the data they're working with and how that might be sonified. And so at that point, it kind of I had to pivot to looking at what is the actual kind of audio engine and what is the lowest latency kind of tech stack for this. And basically, like, what I found was, there's this language, PureScript. It's a functional programming language, and there's several, people that have been developing these frameworks that have just the sort of low latency kind of, they're really focused on audio syncing, scheduling, and all of the tackling the hard problems related to that in relation to web audio, because these are frameworks built on the web audio API. And one of them is a web audio framework designed for interactive media and games, and so it's really good for capturing events like mouse clicks, MIDI notes, and tweening frames that are streamed to an audio rendering engine and that sort of thing. And there's another one that's called Deku that's very focused on speed, and so its event handling patterns outperform React and Vue by like almost 2x. And so it's you want to really cut that latency as much as possible. So another kind of why I think that this is going to be the sort of way to go is it PureScript compiles down to JavaScript, got a rich audio engine, it's interoperable, and so a lot of game UIs can use this because it's built on top of the web audio API. Works in a browser and standalone, extremely low latency latency, and way better than OSC messages, which just frankly aren't going to cut it for the kind of speed that we're all kind of expecting from this sort of thing. And so they're already kind of integrating with WebGPU and WGSL frameworks. And but I think that the main key is that the functional programming paradigm is really well suited for event behavior management, and they built a couple of sort of abstractions that really tackle that really well. And so I'll in the status update, I'll post the examples. They've got like sub 20 millisecond browsers that have synths being controlled by an external MIDI controller, and also standalone a synth player that plays like VMS files, which are kind of used to sort of compose they were used to sort of compose game music back in the day. And some of the I'll also link to descriptions of the necessary kind of abstractions for this to basically to enable separation of the game and the push-pull mechanism of the data to an audio graph, as well as accommodate all of these heterogeneous inputs coming from both on and off-chain data sources. And so I guess I could go, the key ideas is that it's got kind of multiple functions of time. It's got like approximate functions of time as an abstraction, precise functions of time, and integrations over time. And this enables, that sort of encapsulation, but still really a graph that we're going to need to, score and add effects. And the reason why this kind of is so fast is because events are managed in a computationally efficient way, and usually these sort of UIs are sort of coming from a render loop, and this sort of abstraction kind of flips that render loop inside out, where usually events are checked and sent within the render loop. In this sort of situation, a render loop is passed in and events are filtered out from there. But when they're filtered out, they're ignored completely. And so it decreases the computation, whereas, doing that in JavaScript, you'd still have to parse the entire frame. And so that's a kind of big advantage, and really like make sure things can stay fast and in sync. And it even handles events frame to frame, which is also really helpful for like if you're doing feedback loops and that kind of thing. And so that's kind of the I guess the tech stack that I imagine handling the audio engine, and also connecting with the UI API for these games that will have to be there. And so I guess like also wanted to mention that I regarding AI, there's been a link that Yoni sent me about a guy a while back who sort of had this project mapping emotional states generated to sound. and via very simple UI. And I've been chatting with this guy Britt, and he doesn't have the code anymore because it was a long time ago. But he's happy to kind of give me any pointers, like when I get to that stage of having a sort of interface for this sort of tool. And so he's also kind of been more than willing to help. And so and as a whole, everybody has been really helpful because there's just a lot of kind of lot of factors to this sort of project, and game developers have been really great. And it did, especially I was kind of timid to ask the Dope Wars guys or any of these folks, like, hey, can I have even more access, like, to your UI? And so another thing was just sort of I was just also trying to communicate that with this audio project, like the sound and everything would be defined and in service to what their vision and what they've created. And because I'm not sure that when people were thinking composability, they were going to think of the front end as well. But that's the goal, and that's to where you can kind of have this sort of permissionless access to scoring and game audio events, and injecting kind of a music in there. And so that's kind of where I'm at now. And so kind of next steps, like assuming that this is the route to go, and it seems like it is, just from like a latency and performance kind of aspect, that it's getting comfortable in this new language, which is kind of optimized and suited for events and audio. And talking to game developers, because on the UI side, on their side, they're going to there has to be a corresponding API to these event listeners, basically. And that has to sort of get hashed out. And so if anyone is working on getting at that stage where they're wanting to make an interface, we should connect, because a lot of this stuff is going to have to get kind of ironed out, along the way. So, yeah, just talk to a ton of people, got, a ton of, information about what this thing would actually, need in order to get pulled off. And so that's the general kind of gist of what happened this week.
Okay, awesome. So I have like three questions.
Yeah.
And some of them may be stupid, but I'm going to ask them anyway because I'm curious.
Yeah.
So you talked about like something that's very interesting, right? Because when most people think about composability, they think about like on-chain smart contracts, right? And you, I think if I understood you correctly, then the issue of composability also comes into play at the front-end level, especially for your kind of project, right? Because you need access to the UI in order to actually do your music stuff and map it to the, for example, someone clicks on the options tab and it might play sound, right? So you actually have to
Right.
map it to the UI. Is that understanding correct?
That's correct, yes. And that was sort of like, I was kind of hoping that it's not that I was hoping that wouldn't be the case, but it's certainly, you can think of it as composability, but also another dependency, or like another layer in the stack that needs to be connected. And but talking with the Dope Wars guys, it was pretty clear that this was, a lot of the for their MMORPG, that's where the magic is happening and where the events are being generated.
Right, right. And the next question I had, you said you're looking into functional programming languages, and this may also be a stupid question, but just for my understanding in general, the way I think about functional programming languages is that they're not especially user-friendly. So you also mentioned that it does compile
Yeah.
down to JavaScript. So the
Yeah.
question I have would be, if you look into the future and you think about like a finished product or like a proof of concept version that's working, how does that relate to user friendliness? Like if you think
Yeah.
about, yeah, that's just my
It,
question.
well, yeah, and even when I was talking to Mike Solomon, who's built out these functionality, like he said that straight up. He's just like, for every 100 JavaScript people out there, there's like a pure script coder. And so it's I mean, that is a major consideration. And it could be that I uh attempt this in a much kind of poor performing, kind of environment, or that I can sort of encapsulate it kind of small enough. But yet you're right. Like the prospects of people would essentially have to kind of adopt this, as opposed to like maybe something that's a little bit more easy to use. And so that is a consideration that even those guys, the PureScript guys, warned me about. And on one hand, it's like when you look at the sort of code, if you're a algo kind of music person, it makes a lot of sense. But at the same time, you're right. I think the one issue is that the sort of audio graphs are really well established in these frameworks, where maybe like tone.js might not be as well performing. But it's definitely a real factor. I was kind of going for the jugular as far as like latency and performance with this kind of dive, but that practical consideration of like, look, like, if you build it, are they going to come? And so that's something that I think I've definitely got to factor in, going further, and maybe I can sort of genericize or generalize like what this API would be doing. But you're absolutely right. That is a major kind of consideration.
Yeah, so this was less of a criticism and more of a kind of just seeing if there's some kind of way to abstract away this kind of clunkiness that you are used to from functional programming languages, right? So there's,
Yeah.
yeah.
And to that point, because I asked those guys about it, and there's kind of multiple places that the sort of pure script aspect can be kind of encapsulated, and because it's trivial to kind of have that stuff interact with JavaScript or another language, but that it could just be to try to like isolate that as kind of an encapsulated thing as possible, so people can like populate it but not really necessarily interact with the code base, and unless they want to build audio graphs and things like that, or like actual synth patches, which might be a bit more specialized and segmented out of people using this stuff, that could be like a way to go to where it's a lot more adoptable.
Right, yeah, makes sense. Yeah, I mean, I think it's generally a good approach to go for performance, right? Because that's probably going to be the major bottleneck otherwise, and nobody's going to adopt something that has like this kind of laggy feeling to it, right? So it makes a lot of sense in that regard. But yeah, I'm looking forward to see how you can kind of tackle this kind of how should I say, these kind of opposite sides of performance, and then still trying to make it user friendly, right? So
Yeah. And there's also the sort of networked audio thing, and that there's in PureScript there's like sub 100 millisecond stuff where people are like sharing UI components all over a network and connecting that way. But there the again, with that thing of the weakest node being the sort of there being at least as much latency, like my band really tried to find software where we could rehearse remotely, and it still just isn't there yet, and so there are going to be certain limitations to sort of like the networked audio side, and I think that there's just some stronger limitations, I think, that audio imposes, or I guess requirements that audio imposes, that are definitely going to have to be kind of either mitigated or built around as that stuff grows out. But that's where we're at so far.
Right. Yeah, cool.
Hi.
I guess.
Hi, I have another question.
Yeah.
Yeah.
Sure.
Hi. First of all, as a musician, really excited about what you're doing. It seems really exciting stuff. And
Awesome.
the question I wanted to ask was, I understand why some things that are related to the game state, for instance, need to be on-chain, but what is the logic behind bringing the music generation on-chain as opposed to doing it on the client side?
Well, I think like at some point, the idea would be to create like, well, so you're right. Like nothing that I've talked about right now is like Starknet related. Like it's all sort of client side sort of gaming functionality. But um, with I guess the end goal being for musicians to be able to interact with the game state on some way that uh one, there would have to be kind of an interface and like player to do that first, and then ideally you could use Starknet to build sort of game resources, like whether it's licenses to generative models that this audio engine is getting MIDI notes from, or actual like that sort of thing. Basically, for I guess my initial use case was to eventually get like uh, NFTs that are licenses to generative models that can be used in this sort of audio engine.
Understood. Cool. So the idea is to have other stuff happening based on the sound events that will happen on chain eventually.
Right. So in that case, like like if you're let's say you're playing Tetris or something like that, and you've got sounds that happen when you navigate through a menu, or when you reach different like levels, and then so that's stuff that would be maybe client side. But you could also think of, let's say you have like a theme melody for that game, but you want it harmonized in a specific style, and this in this particular person's style. And so it basically uses it uses that person's generative model to, like, say, reharmonize that melody. But it's also increasing with tempo as your Tetris blocks get higher to the top. Or, that's like just a sort of back of the napkin kind of use case that I just thought of right now. But like that would be the sort of idea where you've got that sort of, I guess, component architecture.
Yeah, makes sense. Thanks.
Okay, awesome. Do we have any other questions for Casey? Any questions or remarks? If we don't, then we have a few minutes left. So Tony, if you're here, if you're still listening, if you would like to give us a brief update on the Imperfect Information Protocol project, that would be really cool.
Yeah, sure. So I guess what I can say is that the project is a long way off from being a protocol that's easy for a typical smart contract developer to use in game development. Over the last like month and a half, and really since since I started working on this project, auditable multi-party computation has become probably one of the hottest academic topics in zero-knowledge cryptography. There's a lot of interest in it right now. There are very few, and by that I mean there's one GitHub repo with a sort of functional auditable MPC implementation using ArcWorks, and even that is not it's not good enough for what we need to do this. So a lot of the work that I've been doing on this is honestly just focusing on my own foundations in zero-knowledge cryptography to figure out how to build it. I'm starting to get a bit of an idea of what the very first version of this will look like. It probably looks like a very simple game where the results of interactions in the game are determined by very simple relations, like, if your base ability is above X, then you succeed in this operation. There's another challenge in the design about making the NFTs that have hidden attributes transferable while preserving their hidden attributes. So the the initial design and the initial thing that's built is going to use your private key or some kind of hidden secret as a hidden input to the multi-party computation, and that's what's going to keep your attribute hidden. Obviously, the problem with that is if you sell your NFT, you're not going to give the private key to the person you sold it to. So that's another like open challenge here. So there's a ton of not just programming challenges, but actual like academic research challenges in this project. So that's kind of the downside of like it taking a long time. But the upside is there's a ton of interest in this project. Like even like well-known cryptographers are pretty interested in the work that we're trying to do here. So yeah, I guess, do you have any questions about what I've said? I know I've just gone like super fast, and it's probably just kind of like a word soup if you haven't been thinking about writing actual zero knowledge circuits like I have.
So first of all, I recognize that this is probably the most ambitious project that we have in Matchbox right now. So it's of course not going to be a one and done kind of thing, right? So in terms of questions, you did go a bit fast, but if I understood correctly, you mentioned some problem with NFTs where if you sell them, you would have to basically sell the private key as well. Nobody's going to do that, right?
Yeah,
Can
yeah.
you talk about this a little bit? Because my impression was, or like, why do you have to sell the private key as well?
Well, okay, that hopefully that won't be the end state of this project, but the V0, like the very initial version, will have your NFT will have a private like hidden attribute, but you won't be able to sell it. That's going to be the very first version because the kind of design that I have right now is okay, you mint an NFT and you generate some public attribute that's actually in the NFT storage. And then you also use your private key as a mix. So you have some function that will essentially hash your private key with this public attribute to create whatever your hidden attribute is in the game. So, for example, a value between 1 and 100, if it's like a base ability for something. So then, like, let's say that it's a racing game. If you have, 5 people entering a race, everyone can provide their private key as their secret witness, like their hidden input to the race simulation. And underneath the hood, so like inside of the multi-party computation, you'll have this hash function that's combining the private keys with the public attribute to give you actually the value that's used in simulating the race. And none of that's going to be revealed whenever you generate the proof at the end. The only thing the proof's going to reveal is who won the race. So this is like the first design for it, and this is something that's probably possible to do today, but not straightforward to do. Hopefully a later version, hopefully there will be some design breakthrough that allows us to either structure this in a different way or get by use something else as the hidden input to the multi-party computation to allow it to be sold while preserving the attribute underneath the NFT. Does that kind of make sense? Like what the issue is there?
That makes a ton of sense, and that would be my follow-up question, to just use a different input to generate this hashed function, right? Because I understand why you use the private key to hash it with something to get the unique attribute for your personal NFT. But my question would be, why can't you or can you use, for example, a chainlink VRF function to achieve the same thing?
Well, not a VRF because you need the value to stay static. Otherwise, the hidden attribute is going to be changing every simulation. The other thing is you need if the hash function is known, like if someone has a private key and a public attribute and they know how to construct the hidden attribute from that, then you also need some incentive to stop people from colluding by revealing their private attributes to each other, or like their private key in this case. And obviously, like private keys, there's a really strong incentive not to reveal them. There are sort of like, I have some thoughts about how to work around this. You could almost imagine like running a game server that has another hidden piece of information in there, or you might be able to construct some kind of check that the hidden attribute is staying consistent. But I mean, the honest answer is this is not a solved problem. It's not something that I necessarily know how to do yet, but hopefully gonna figure it out eventually.
Right, and probably another stupid question, but could you not somehow use CK proofs to obscure some parts of information, or like the input that you would be using instead? Like, is there no kind of way to make that work?
Sorry, to obscure the input, like to hide the input?
Yeah, like because you said you have to stop people from colluding, which means you have to stop people from, for example, revealing their private key. And in the private key example, it's not a big issue, right? Because people will not just reveal their private key. But if you use something other than your private key, then can't you use CK proofs or something like that to reveal that, or make it even unrevealable, or something like that? I don't know if that makes sense, but yeah.
Well, I guess yeah, it doesn't totally make sense to me. Like, let's say that I give you a secret of, like, let's say it's the number 1 million. And I'm like, this is your secret. Don't reveal it to anyone. It's going to be your input to the multi-party computation for your NFTs. There's no way for me to prevent you from, telling Yoni your secret, right? Like, I can't stop you from doing that. Even if we use some kind of obfuscated version as the input to the multi-party computation, you could still collude with Yoni by revealing your secret. Does that make sense?
That makes sense, but is there no way to have the secret and me not knowing it in the first place? Like, generate a secret number and I don't even know what it is?
Well, and then you've got to think, where are you going to store it? Right? Like, who does know it?
Right. And that's
so
I guess
that's the problem.
But that's, I guess, where CK proofs could be useful, right? Because they obscure information.
That's right. Yeah, they do obscure information. So you're able to use these inputs in a simulation with other people without revealing them to them, right?
Right.
But the problem is you still have to keep a number consistent, you still need to store it somewhere. So there's a field of research in cryptography called indistinguishable obfuscation, or IO for short. And this would be kind of what you're talking about, like perfectly obfuscating a value where you can still do any kind of complex operation with it, not just simple ones. And this is like not practical to use today. Maybe it will be one day, but it's not. You can't use it in production today.
I see. And the reason why you can't use it is because it's like the performance right now is just not there, or any other reason?
Yeah, like performance and just like not totally understood, not a solved problem. Yeah.
Gotcha. Okay, makes sense.
And I mean, it's related. Actually, if you're interested in the math, it's related to some of the like deepest topics in complexity science, probably. So like, whether indistinguishable obfuscation is ever going to be super performant is related to some like really deep mathematical things about computation in general. So I think it's interesting.
Okay, I see. Makes sense. Thank you for elaborating on that. It's really interesting, actually. Yeah.
Yeah, no worries. Thanks for letting me share with you guys.
Yeah, of course. You're welcome. Does anybody have other questions for Tony? If we don't have any questions, then I would like to thank all of you for coming. Yoni, do you want to say something?
Yeah, I had a small question. So Tony, what's the first application will look like? Maybe I missed that part, but I mean, so let me make my question more clear. What part of the state will be hidden? Will it be the state that the game developer usually see, or will it be like
Yeah.
partially hidden from one of the developer, like what you're planning for the proof of concept?
So I think in the very first implementation of this, the owner of the NFT will be able to know the hidden attribute of the NFT that they own.
But no one else.
And no one else will. Yeah, no one else will be able to reconstruct it. I think, and they will be able to use it in like fights or races or whatever. Like, I mean, fill in the break, whatever interaction you want.
Oh, sweet. So even inventory, for example, that someone have a bunch of NFTs as an inventory, and then like only he knows his inventory, and also
Yeah,
in
that's
poker. Nice, cool.
Yeah. Obviously, it would be better if also the owner of the NFT didn't know. But I think that it's probably easier to implement first where they will be able to know.
Sweet. Thanks.
Okay, awesome. Yeah, I would like to wrap up this call now. I would like to thank all of the grantees today who have presented and updated us all with their progress. This has been a really sweet dev call. Lots of interesting stuff, lots of great discussions. Thank you all for attending. Thank you for your discussions, and see you guys next week.